passed out, and you'll have to, when you're done playing, pass them back so everybody can play. There's iron filings in here and a magnet. And in the movie that we just saw, it said the sunspots on the sun are like magnetic storms on the surface of the sun. And they make these patterns because the sun is a ball of gas. It's a ball of plasma, and it acts the same way that these do. It has those same spiky structure, the sunspots. And when the magnetic fields on the sun are strong and get tangled up, a jet of these charged particles, plasma, goes flying off into space. And if, there's a lot of ifs here, we happen to be, the Earth happens to be right in the way, then we get hit by a stream of charged particles that's more powerful than usual. And that's when we have aurora. So the presentation that we had was about aurora, and then I'm going to talk a little bit about where to go to see aurora and when to go to see aurora. My name is Diane Turnshek. I teach astronomy at Carnegie Mellon University and at the University of Pittsburgh. I have 2 faculty positions, and I started doing this back in 1981. So after I do my presentation, you have any questions about astronomy at all? I am testing you. See if you can beat me on any question about astronomy. So we are going to be having aurora in the next day or 2, which is really rare. But right now, the sun is in a very active state. The sun has a lot of sunspots and then a very few sunspots, and then a lot of sunspots and very few sunspots. It's every 11 years we have a lot of sunspots. And this is the most active I have seen the sun in the longest time. So we just happen to be at the peak of this cycle. It's called cycle 25, and it has been shooting rays and charged particles out into space. So it just got announced that there was a big jet of these charged particles that came out of the sun, and then a day later, another faster one that came out of the sun. It's an X9.1, if you're counting. And it's catching up to the first one, and so the 2 of them are going to hit each other and then hit us all at the same time. So the place that I go to learn about these things is called Space Weather, spaceweather.com. And it tells you all about what's happening out in space that might affect the Earth. So as these charged particles come in towards the Earth from this big explosion on the surface of the sun, it can't cross magnetic field lines. The charged particles have to spiral along magnetic field lines and then come in at the poles. So if they hit the main part of the Earth, they will spiral both ways and come in at the North Pole and the South Pole. And people that live in the North and South Pole see them all the time. People in Finland see them frequently. People in Florida and Texas rarely, but sometimes, see them. And here, I've lived here for a while now. I've seen them perhaps 5 times, which is pretty good. This is what spaceweather.com shows you when an aurora is coming. This is called an auroral oval. The peak is at the pole, and then it gets bigger or smaller and changes color when it's coming and it's going to hit. So we're watching now. So if you are in Pennsylvania, you are in Pennsylvania, in case you wondered. The biggest part of the oval is now over Asia, and then it will swing around. So typically, you see aurora mostly late in the evening, like midnight, 1, 2, 3 a.m. That's why you haven't seen them very frequently, because you are usually sleeping, I take it, at that point. Or at least you're inside if you're playing video games. This is the prediction for coming up, the first one, and then the second one, and then they are blending together, and by the time this red part swirls around, it should hit tomorrow night, which is interesting. So sometimes when you see an aurora, it's not like, for those of you who watched the movie, it's not like rippling, rippling. They sped up those very fast. You could see the people walking and the cars driving by, and you know they sped those up. They're peaceful and quiet and gentle, rippling curtains, shimmering lights, because the charged particles are hitting the atmosphere, and they're exciting atoms in the atmosphere. They're exciting the nitrogen, which is most of our atmosphere, and the oxygen, which is 24 plus something percent. And those are giving off green and red and sometimes other colors of light. This is the one that we had in May. I don't know if anybody here saw them. You must have seen. You didn't see the May one? A little bit. Yeah, I live in the city of Pittsburgh, but I live in a very weird part of the city of Pittsburgh. I bought 8 acres of woods up near Hayes Woods, and I can see the Milky Way sometimes from the city, which is very strange. So I saw the aurora, bright red overhead. It was beautiful. And sometimes you take pictures with your phone and the extended exposure shows up things your eyes can't see. So this doesn't really look super bright, but this was Dylan, one of my students, and you could see some of the red, and then down here, some of the green parts. I think my computer shows it better than that. Here's my picture from my deck. This is looking towards the city of Pittsburgh, because I'm just south of the city. And that's not where you want to be to see aurora. So the things you want to do to see aurora is find a dark place, but also not so your northern horizon is full of lights. You want to find a dark place where maybe the city is behind you or to the sides, or a town even, or fracking. So what are aurora? Charged particles coming from the sun spiraling along the magnetic field lines coming in at the poles. What do they look like? Pretty, shimmering, beautiful, wondrous, awe-inspiring, should be on your bucket list, pretty lights in the sky. We don't see them all that often here. The one funny story, I don't know if it's funny, I was teaching at St. Vincent, which is kind of south. I was driving up towards Pittsburgh, and the entire sky went red. And I thought somebody blew up Pittsburgh. It's like, me, of all people who can recognize aurora when I see them, I should have known that that was an aurora instantly, but my first thought was like, oh, my kids. But that's another thing. So not only do you have to be up at 3 in the morning, not only do you have to be outside looking up in a dark site where there's not bright lights to the north, but you also have to know what they look like. They're not really fast. Sometimes they look like a car dealership lights, just white streaks going up in the sky. So you have to be aware of what a normal sky looks like so you can tell that it's different. We're in this very active sun cycle right now, but there's one more consideration, the moon. When the moon is in the sky, it's really bright. And you're not going to see hardly anything if the moon's up. If the moon's full, you could read by it. It's very bright. So you have to think about this cycle the moon goes through. It goes through phases every 29.5 days. That is from new moon through waxing crescent, first quarter, waxing gibbous, full moon, and then the waning phases are the second part. The waxing phases mean getting bigger. The waning phases means the moon's getting smaller. I asked somebody in my class one time, give me a sentence using the word waning, because people usually don't use that. And somebody in the back goes, my attention is waning. It's like, Good, thanks. That's exactly what I was looking for. So waning is when the moon is getting smaller, 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 then it's a crescent, and then it's gone. So once you know that, when you know when the phases are coming, those are the days when you can go out and look. And right now, we're in a good place. We don't have a moon. So these charged particles are like that north-south that some people saw in the movie. It's like a magnet with a north pole and a south pole. And on our Earth, it does change every many, many thousands of years. So the north becomes south and the south becomes north. And in between, the magnetic field disappears and then reappears in the other direction. We know that because we look at the expanding levels in the center of the ocean where the continental plates are drifting apart and lava is welling up, the magma down here, and as it solidifies into rock again in this spreading ocean floor, it's magnetized to show us north is that way, then north is this way, then north. And so we can tell how long it's been since each phase. And it is moving into a phase now where many thousands of years in the future, the magnetic field of the Earth will disappear and then reappear in the other direction. I do not think there's going to be any problem because we will have thousands of years of notice about this. I'm sure we'll figure something out. The movie showed the city going dark and that deep voice going, destruction. I was like, yeah, no. Nothing to lose sleep over. Because when we're all in the future in 2,000 years, just, tell me about it. So these charged particles, they glow in this interaction. So the aurora that we might see tomorrow night, it would be very nice, come from the sun. There's this shock, the bow shock pushes the magnetic field lines so they're not even and nice and uniform, symmetric, and it flows the magnetosphere back outwards, and then some of them, when they come back around together, they snap, and the charged particles go in at the poles. And that's why it looks like they're spiky, and they shimmer, and they're bright, and then they dim out, and they're bright again, because it's this interaction with the magnetic fields. These are an auroral oval, an ISS seeing the aurora, and really pretty aurora pictures. If you want to do photography of aurora, we're going to talk about that in a minute, but always putting something in the foreground, super important. A house, a tree, a person standing there really still. But it helps with the whole scale of things. So it gets cold and you're laying back in a chair or on the ground and you're gonna freeze, dress warmly. If you're gonna go out somewhere and it's summer, take a coat. Go in wherever you keep your coats in the summer and dig one out. Take a blanket, take 2 blankets. Bring something hot to drink like hot chocolate, hot tea. You don't want anything to your north that means not a bright city, but also not huge buildings, huge trees. You want to not be in a valley where there's only this much of the sky that you can see. You want to be kind of on a hilltop like we are here. There are chairs. They call them zero gravity chairs. Have you ever seen those? They're so comfy. They're like a lounge chair, but then they go the whole way back. That's like, you're really there if you're doing that. Red flashlights are good, or your phone with a red app on it is good. I have a red headlamp. But red light does not shut down your night vision. Red light is fine. It doesn't affect how well you can see. So you definitely want that. And I'm always worried about safety. And I have to ask people who know this area, wild animals? I mean, are there in this area coyotes, bear? No. But probably wouldn't bother a group of people, no. So bring friends. Yeah, that's my suggestion there. I don't know. And there's aurora on other planets, which is so cool to see. We have seen aurora on Saturn and on Jupiter, which is nice. Whoa, that was interesting. That I should have known that it could do that. Okay. So here's another thing to think about, light pollution. I have a lot of kids. And so I took a nice chunk of decades of a break from work to raise my kids. And I came back to work and I found that it was hard because computer languages had moved quite past me and I was floundering what to do as an astronomer. And so I decided that what I was going to do is I was going to make the world darker for astronomers. That was my job. I took it upon myself to fix light pollution all over the world. That's a big job. But I've gotten a little ways. So here's the US. These are satellite pictures of the US. It kind of means you're not doing very well if you're east of the Mississippi. There is a map called lightpollutionmap.info, and it shows you this is Pittsburgh. So if it's red or even worse, white, it's not good. And then green is good, blue is good, and then there is a darker blue, and that's what we're looking for. So here's where we are in this area. And if you go to Ohio, this is the border. If you go to West Virginia, I take students down here to West Virginia. Most people go to Cherry Springs, which is like up north. But even out here is nice. There's Park here, just south of Uniontown. That's a little far. But even if you're in the middle of this blue area, you should be able to see a lot of stars, like 1,000 stars. Normally, if you're in a dark area, you're seeing 5,000 stars, which seems so amazing, doesn't it? From the city, you see like 12 or 50 if you're in a dark spot. Here, you can't count. Go and try and count. So that was my goal there, was to make Pittsburgh dark, because I live there first. And so we have dark sky ordinances now. You're welcome. And we have new street lights coming in that are going to be 2,700 Kelvin, which is a very amber color like this, not bright white like these other lights. Starting in February or March, they're changing out 37,000 street lights, shielded so the light doesn't go up, and just where you need them, when you need them, like some of them are dimmable, and it's going to be a lot clearer dark skies. But still your doorways and your walkways and your roads and your side, they're all lit up, but the skies are going to be darker. So I'm pretty happy about that. So finding a dark site, look on the maps and just drive in the middle of nowhere, basically. You don't want to have something where it's bright to the north if you're looking for aurora. And then weather forecasts. So these are a whole bunch of pretty pictures and slides of block O text. And if anybody wants this presentation, I will send it to them. If you want to take a photograph, iPhones are wonderful now. You can set a night mode and an exposure time. You can prop them on just a little thing, like lay them flat on a deck rail or whatever. Like, you don't need fancy equipment now. But if you do have a DSLR camera, you want something that's wide. Telescopes are not going to do good. Telescopes have a little field of view to them, and the aurora are the whole sky. So you want something that's wide when you take a picture. The tripod's important if you have a camera. You don't want to lay an expensive camera in the grass or something. So a tripod will steady the camera up, and a lot of times they have a little a wire that comes off where you can click to take a picture, so you don't have to push the camera to take a picture because that wiggles the camera. So you either need a remote shutter, or maybe it's got a timer on it, so you set it to, you know, go off in 10 seconds, and then you step out of the field of view because it's wide. And then cold temperatures, your batteries die so fast. If you're out at night, that's the first thing is you always carry extra batteries, extra memory cards, because you're going to be so fascinated. You're going to be like, oh, look at that. Click, 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 click. More and more and more pictures. You don't want to run out. So this is the color of the sky when I thought somebody blew up Pittsburgh. I was like, what just happened? Isn't that gorgeous? So a lot of these pictures I get on Unsplash, which is a free website to just use pictures. Manual, some of the cameras can do things in automatic mode, but I don't trust it for something like Aurora. And you want to set the shutter speed to be pretty long, like 5 to 15 seconds is good. The problem is Aurora do shift. So you can't do a 20-minute exposure. You're just going to get a blur of things. So you want to take many small frames and then stack them, add them together. And the focus, if it's just focused on a star or infinity, you're good. Like, that's far enough. I really love these. But almost all of the pictures where you see Aurora, you're also seeing snow everywhere because, and what happens if you want to go north? It's on your bucket list, you got to check it off, so you go to Reykjavik. And you go in the summer, because who wants to go in the winter? Yeah, in the summer, it's only dark for like 2 hours. So those are not the best time. The best time, if you want to go north and see Aurora, is go when it's like 20 hours of darkness, so you have a better chance of catching it. Composition, so put things in the front, and this is, you know, this is an experimental thing. You really have to experiment with it. Nowadays, in post-processing, a lot of what amateur astronomers are doing is taking out the photos that had satellite streaks, which are coming more and more and more frequently now. Every time you take a picture anywhere, there's like, oh, there's 20 satellites going through. And so it's very difficult to take those out of the picture. And most people don't want those in their photos. So that's one thing when I talk about I work with light pollution, I also work with space-based light pollution. So I am in conversations with SpaceX and other satellite companies, OneWeb and Amazon Kuiper, and we want them to not put bright satellites up all over the world because they didn't ask anyone. And there are a lot of people who don't want that. They want their pristine sky. There are indigenous people who still teach lessons using star patterns and taking and putting so many satellites up. SpaceX has asked for launch capability for 1 million satellites. Every star in the sky will be moving, and then where's your sky? You know, so there's a lot of people and animals who navigate using the stars or using the Milky Way, and it was not a consideration. SpaceX put up one that they blackened, but that one got too hot. You put a satellite in the sun, of course it's going to overheat. They put up a few that were called visor sats. They had a visor covering all the shiny bits, so it wouldn't reflect as much sunlight back down to Earth. And then they said that was too expensive for them. And then they put up some satellites they're working on now where as the satellite launches, they turn it to the side so the sunlight will not bounce down towards Earth, but bounce off the reflective parts back up into space. So they're at the table, we're talking. It's a bad process because they have all the money and all the power, and astronomers, it's like, in our spare time, maybe we work on this. But the latest ruling was that there has to be an environmental study done before they can launch. So they have to say, are they depositing too many chemicals in the upper atmosphere? How's that changing things? We don't know. And what about the debris? Because those satellites have a 5-year lifespan. And when they come back down to Earth, it's an uncontrolled deorbit. They just crash anywhere. And then SpaceX goes and picks up all the debris and takes it away. And the farmers go, who were those people? But, we're working on it. We're trying. Also, if you go out, it's always good to have an emergency kit. You never know. There's holes in the ground. Generally, I say, if you're going to go somewhere, go during the day and look at what it looks like, where the holes are, where the things, logs you're going to trip on and branches you're going to hit your head on. Go during the day. Maybe that stump looks like a bear at night, but during the day, it's just a tree stump. So you can check the area out first. And a lot of people are scared to be out in the dark. And then I'm like, play music. Bring your dog, bring your friends, stay by the car. Just do it for 10 minutes, and then the next time 15 minutes. You'll get used to it. It's a process. But if you've never done it, it's a hard process. There's one. And then we have forecasting tools. And I'm way over time limit here, so I'm just going to tell you that there's a bunch of them. I use spaceweather.com. I think that's fine, but they don't have when the moon phases are. So some of these other ones, time and date, and NOAA's space weather, SolarHam, or the last one, those do have like the moon and the aurora. But thank you. And now, questions.
I have a question, not so much about auroras, but about the plasma ejections, the sunspots, and so on. What are the predictors of the plasma ejection, especially a large one? What tools are used to predict that?
So they're pretty unpredictable, but we can see groupings of sunspots, which one magnetic field is going out, and then the other magnetic field line is going back. So they're usually in pairs. And if those get bigger and bigger, groupings of them get bigger and bigger, eventually that loop of plasma will just break and just spew out. That's called the coronal mass ejection, CME.
So it's not so much a prediction, it's an observation based
Yeah.
on an observation. It's about to let you break. Okay.
Right. The sun rotates, just like the Earth rotates in 24 hours, the sun rotates in about 24 days. But it's different at the equator. It rotates faster, like 25 days, and at the pole, it's like 30 days. Isn't that weird? Because it's a ball of gas. It doesn't have to rotate together. So it's a differential rotation. And that's why we have sunspots in the first place, because the magnetic fields are inside the plasma. And if you're rotating faster here and slower here, everything gets tangled up. And then snaps, and there's no magnetic field. And then when it comes back, the South Pole is now the North Pole, and the North Pole is now the South Pole. So every 11 years, the sun switches its poles. And so we watch the magnetic fields and how they're generating sunspots, and we can see what's coming.
By the way, around here, the most troublesome animal you likely to encounter in there?
Skunk.
Skunks.
Skunks. I hate skunks so much. Oh my goodness.
Especially in this late winter, early spring, the young skunks are out and they don't have much control over their.
Oh, geez. Oh, look at the little pretty kitty. Oh, yeah, I've done that. It's like, yeah. Oh, that's a terrible one. There's nothing you can do, right?
They will chase people out of Kennywood.
Oh, I did not know that. Did you have?
What source do you use for your light pollution maps? Is it one for the whole country? Or?
So the VIRS satellite is the best, VIIRS, and some of those light pollution maps were from that, if you just go to light pollution map. The problem with that one is there's a spectrum of light that comes from the sun, red, orange, yellow, green, blue, indigo, violet. Well, that satellite was put up not to measure blue or violet. And so it misses all the new LEDs, which are basically in that region of the spectrum. So that's not a really good way to do it. So I have used drones over the city I got blanket permission to fly my drones anytime I want over the entire city. I'm so like crazy with this stuff. I had a guy, I slung a camera underneath his aircraft, and he just went in a lawnmower pattern back and forth over the city. Only if you look at it, there were too many gaps. Like if somebody cut your grass like that, you would not pay them. It was like over here and then way over there and then way over there. I flew over the city in a helicopter with the doors off, with a camera leaning out, taking pictures. I have astronauts who are taking pictures for me when they go overhead, which is very nice of them, but they go really fast. So when they get a picture for me, it's like, well, there's Pittsburgh, whoop, there's Cleveland. Like they go around the whole Earth in 72 minutes. So they'll snap a picture, and it'll usually be like from before or after Pittsburgh, but it's working. I want to get before and after shots when they change the street lights. I want to know whether or not we did a good job. So I'm like the watchdog, so make sure they do a good job.
Do you feel like it's better to be a higher like vantage point or be like the best stars I ever saw were in a desert and it was like very flat. I was like amazed because I was like, we're like into the stars. I'm used to looking like up at stars, but looking like in is weird. But I was wondering if you're higher, which is like better.
So the astronomers that have telescopes like on Mauna Kea, where you're above a third of the atmosphere and it's hard to breathe.
Well, I'm not really high though.
Yeah. It does help to get above some atmosphere, but that's not really the thing. The thing is you want it dry. So your desert was probably amazing. Because where we are, even when it's not, even when it's clear, there's so much water in the atmosphere. So you just want a clear horizon, which is hard to do in Pittsburgh. So it could be flat, or it could be in the top of a hill. Those are the best spots. Yeah, there is that feeling when you see a good night sky and you realize that you're not really looking up into the sky, you're looking out to infinity, and it gets you dizzy, like vertigo, like you literally feel like you're lifting up into the stars. They feel so close you could touch them. It's an amazing thing. And if you haven't seen it, it's hard to tell anybody about it.
I woke my kids up at like 2 in the morning. I'm like, get out of the car. We're like 150 miles from all the towns. Get out, wake up.
Oh yeah. Do you want to move to the next? Because you have the schedule here. I'll just stand out there. And
If you have further questions, I'm sure Diane will be willing to talk with you outside. We're going to take a little bit of a break. I have a special group that's coming in for a special presentation. We've got some Cub Scouts here. And so then once we're finished with that, then we're going to show the movie that we showed before, Arcs to Auroras. So if you saw that movie and make the announcement, you don't need to make your way here. It'll be the same movie. Usually show the same movie a couple of times. And always, especially right now, I want to double check, see if there might be an aurora out there. I made the trip to Alaska in February, and it was interesting because when you're looking through a camera lens, you see these beautiful green and red lights. But if you're just looking with your naked eye, you really have to kind of pay attention because it just looks like really faint. There might be a greenish tinge over there, and that's the aurora. So if you're outside and you